Hey guys, how's it going? Here we are once again with actually the final video for this chapter 4b, which deals with transformations. And today we're actually going to go on and move on to the final set of transformations that we're going to talk about for this chapter, which is rotations. Alright, so we've had a little bit of a brief introduction on rotation in the past. We went into more detail on the other two sets of transformations, which were reflection and translation. But today we're going to focus mainly on rotation. So we're going to go ahead and try to identify the angle of rotation, and we're also going to draw rotations on the coordinate plane. So very similar to translations and reflections, we're going to have a certain set of criteria that we have to meet in order to have the proper uh, the proper uh, the proper transformation, in this case being rotations. So we're going to go ahead and talk about the angle of rotation first, okay? Now, if my angle of rotation is 90 degrees, this is what happens. My x and my y, essentially, so you're going to go from x comma y, and then after that rotation of 90 degrees, you're going to end up at negative y comma x, okay? And actually right here on our diagram, they showed us a good example of that. So if you start off with like 5, 2, you're essentially switching your x's and your y's. So to 2 comma 5, but this one you're going to make it negative. So this is going to be negative 2 comma 5. All right, and that's exactly what we show here in both of these points on the right. Okay, so that is what an example of a reflection, of a rotation of 90 degree looks like. Okay, so let's go ahead and actually read the description first though. It says to rotate a point 90 degrees counterclockwise about the origin, you multiply the y coordinate by -1 and then interchange the x and the y coordinate, which is exactly what we did. Okay, we changed the x's to y's, and then we just made sure that that new x value had a negative in front of it. Okay, all right, so that is the rule for 90-degree rotations. Now let's take a look at 180-degree rotations. This is our rule. So for any x comma y, again, I'm going to go ahead and use the example we have in the diagram. Like for example 5 comma 2, we're just going to go ahead and make both values negative, or rather we're multiplying both the x and the y by a -1. So this is going to be a -5 comma -2. And as we can see on the description, it says to rotate a point 180 degrees counterclockwise about the origin, you have to multiply the x and the y by -1, just like I said in the past. Okay, as you can see already from here, this is where we started. I want to reflect the whole 180 degrees. I'm sorry, rotate. I keep saying reflect, but I want to rotate counterclockwise 180 degrees. I end up there, and my new coordinates are -5 comma -2. That is what a rotation looks like as on the coordinate plane, and we'll see that a little bit more in a second. Okay, so let's keep all of these in mind, guys, these rules here, because those are the ones that are going to help us identify our new images in the next few example problems. Let's move on to the final rotation, which is 270. And in this one, we are actually going to go ahead and turn every x comma y. So I'll do another quick example here. If I have 5 comma 2, once again, we're switching the x and y. So I'm going to put the 2 here and the 5 here. But now I'm making my y value negative. Okay, whatever is in this position, I'm going to change it to the opposite of that. So in this case, it was a 5, but I'm going to change it to a -5, which once again, you can definitely see on these 2 points on our graphic. All right, so it says to rotate a point 270 degrees counterclockwise about the origin, multiply the x coordinate by -1, and then interchange the x and y coordinate, which is what we did. Okay, I think I just did them in the reverse order. I switched them first, and then I went ahead and changed them. Okay, it doesn't matter which way you do it, it'll always turn out to be the same. Just keep those two things in mind, okay, guys? All right, so let's actually go ahead and do some of these example problems. Now, what I've told you guys in the past, and let me zoom out of here. These tables, guys, I know some people take them for granted, but these tables right here on the top of every single set of notes that we've done so far, that is your bread and butter right there, guys. That's everything. That's all you need for the entire set of notes, okay? Keep those things in mind. We're going to continue to reference back to those, all right? So let's go ahead and start with our first example. It says rotate XYZ, so triangle XYZ, 180 degrees to create triangle X prime, Y prime, Z prime. So this is the main thing here. We want to rotate 180 degrees. So what is our rule for 180 degrees? It is x comma y turns into negative x comma negative y. X comma y, negative y. I'm going to keep that on the side there so I know what to do. So let's take all these coordinates. Let's see, this is going to be 4 comma 3. This right here is 9 comma 3. And this here is 9 comma 8. So what I'm going to go ahead and do is take my z prime. Actually, I'll do my x first. Let's go ahead and go in order. My x prime is going to have, well, it's going to turn a 9 comma 8 into a negative 9 comma 8. So negative 9 comma negative 8 is going to be right up here, or rather right down here. Negative 9 comma negative 8 is right down here. Okay, and then I'm going to go ahead and do my y prime. Well, that was 9 comma 3, so it's going to be negative comma negative 3. So negative 9 comma negative 3. And then finally my z prime. It was 4 comma 3, so now it's excuse me, it's negative 4 comma negative 3. So negative 4 comma negative 3. Right there. I can go ahead and draw my new image. My new triangle x prime, y prime, z prime. Okay, so this was the rule that I followed here, and that gave me these new sets of coordinates, and that helped me find the rest of this out. All right, so keep those things in mind, guys. Again, notice that I had to reference back up to the top chart in order to figure out what I had to do. All right, this next one says to rotate 90 degrees, triangle EFG. So let's go ahead and do it. Let's find our rule. To rotate 90 degrees, I have to go from x comma y to negative y comma x. X comma y to negative y comma x. Let me make sure that's right. Yes, yes it is. Okay, so once again, let's go ahead and find our coordinates here. This is 1 comma 7. This is 3 comma 4. And finally, this is 2 comma 1. So my new coordinates have to be E prime, F prime, and G prime. Okay, so I have to basically make my Y a negative. So this 1 and 7 for E is now going to be 1 negative 7, but I have to switch them, so it's really going to be negative 7 comma 1. Next one is going to be F, that's going to be negative 4 comma 3. So not only do I make the first one a negative, I have to switch them. And then same thing here, negative 1 comma 2. Let's go ahead and graph that. That is going to be negative 7 comma negative positive 1 right there. That's E prime. Negative 4 comma 3 is F prime. And then negative 1 comma 2 is G prime. If I graph that here. That is it. That is my new figure. That is my image. Alright? So again, guys, notice once again, I have to go back up and find out what it was to rotate 90 degrees counterclockwise. I wrote down my rule, and I followed that rule in order to do the rest of this. Alright, I'm going to actually have you try number 3 on your own, but let's go ahead and see what's being asked. We want to rotate 270 degrees counterclockwise. We're rotating that triangle, so let's find our rule. It is x comma y turns into y comma negative x. Comma y turns into y comma negative x. So not only are we turning our original x into a negative, but then we have to switch spots with the y. So why don't you guys go ahead and pause the video at this time, and please try that one out, please. Alright guys, let's see if we got this one down. So first off, let's go ahead and put the coordinates. This right here was negative 3, 9. This was negative 2, 2. And this was negative 8, 4. Alright, so let's go ahead and find out where L prime, M prime, and N prime coordinates are. Okay, so once again, guys, I have to turn my x into a negative. Alright, so let's look at L. Well, the x here is already a negative 3, so it's really going to turn into a positive 3, but then we have to switch the roles. This 3 is going to come to the y value, and this 9 is going to come to the x value. So I really am going to have 9 comma 3. And then for m prime, I'm going to have 4 comma 8. And then finally, we're going to have 2 comma 2. Let's go ahead and graph these. 9 comma 3 is right up here. This is L prime. 4 comma 8 is right up here. This is M prime. And finally, we are going to have, let's see, N prime is at 2 comma 2. Right there. We go ahead and graph this. And there we go. Kind of looks like a reflection, but it's actually not. It's actually a rotation. And again, I can show you guys visually what exactly is happening here. Okay. On here, if you guys want to take a look at number 1 once more, this Z value, it reflected it rotated a whole 180 degrees. Every single one did. The X did as well. The X rotated 180 degrees, and the Y rotated 180 degrees. Okay, so all those rotated 180 degrees. All right, here we go. Let's see. All right, so let's go ahead and take a look at this one. I want to show you guys exactly what happened here. This rotated 90 degrees, 90 degrees, 90 degrees. Okay, and then this one just went a whole 270. So I'll just show you one example here. This went all the way around and came back up here. So like 3/4 of an entire circle. Alright? Alright guys, why don't we go ahead and, again, these lines here, if you want, just go ahead and erase them. You don't need them. I'm just kind of showing you more conceptually what's going on here. You are rotating each one of those points along some point of rotation, which we don't show you here exactly where it is, but that is exactly what's happening. Okay? Alright. Let's see. Where are we going from here? We have to go ahead and do problem number 4. Alright, let's go ahead and see what number 4 is being asked. It says identify the angle of reflection about the origin between the given images. Okay, so we have ZUGF. To a new ZUGF, we have to find out how much I rotated, whether it was 180 degrees, 90 degrees, or 270 degrees. So how can we do that? Well, an easy way to do that is this. Let's go ahead and find the coordinates for one of them. The coordinates for my Z is what? It is 2, 1, and the coordinates for my Z prime is 1, -2. So let's compare those. I'm just going to go ahead and do this right here, and then we're going to compare them, guys, okay? So this is my original. It was 2, 1, and it's turning into 1, -2. All right, so we have three choices. Well, first off, let's notice something. It looks like the X and the Y are switching, right? So it's definitely not going to be 180 because the X and the Y stay where they're at. They just turn negative. So it's not going to be 180. That one's out. So it's between 90 degrees and 270 degrees. Okay. The question now is going to be, which one did we turn negative? The X or the Y? Well, let's see. It looks like this value here is the one that turned negative, which was the Y value, or the one that goes in the Y spot. That's right here. Notice that? So this is actually going to be a rotation of 270 degrees. Okay? A rotation of 270 degrees. Counterclockwise of 270 degrees. The rule was xy to y negative, whoops, y negative x. Okay, again, if you're not convinced, guys, try it out. If you're just given a regular 2, 1, you have to translate it. You have to rotate it according to this rule. Then let's see what we get. Well, my x turns into a negative and then it flips and switches spots with the y. So my x originally was a 2, now it's going to be a -2, but it has to switch with the y. So we switch them. This is the exact same thing as that. So yes, we have a rotation counterclockwise of 270 degrees. Okay, we can do that for any of these guys. So let's go ahead and do this one. I'm going to use let's use the H's. Why don't we use the H's? So H and H prime. The original H is 1, -2. And my H prime is 2, 1. Okay, so let's look at the rule. Let's see if we can figure out this rule here. So my rule is going to look something like this. But originally, I had 1, -2, and now it has turned into 2, 1. Well, once again, guys, my roles were switched. My 1 that was originally an X is now a Y. Okay, so let's see which one does that. Which rotation does that? Which rotation makes my X now a Y? Right here. My X is now a Y. So that is my rotation. That is 90 degrees counterclockwise. So again, let's write down the rule. X, Y, which makes sense. Look, my -2 is now a +2, and my x's nothing happened to them, they just switched roles. Now my x is a y. So this is rotation counterclockwise of 90 degrees. Okay, I'm actually going to give you guys a shot to try this one on your own. I would say concentrate on, it doesn't matter really, but why don't you guys go ahead and concentrate on the C's. Write down your coordinates for C. Here it was 4, -2, and here it is -4, 2. So go ahead and take a second and try this one out. Alright guys, let's see if you guys can figure this one out. So first off, I'm going to have a rule. We have to figure out which rule that is. Okay, and then the originals that I had were 4 comma negative 2, and then turned into negative 4 comma negative 2. So one thing I noticed right off the bat here is that the 4's stay as x's, the 2's stay as y's. The only wait, my bad. This is a positive 2, my bad. So the 2's stay as y's as well, except for now their symbols are switched. So which rotation tells us to keep the symbols or keep the numbers where they are, just switch the symbols right here. 180 degrees. Okay, the x's are still there and the y's are still there, but now we just make them both negative. So my rule here is negative x, negative y. That is a rotation of 90 degrees. Oh, I'm sorry, 180 degrees counterclockwise. Okay, rotation of 180 degrees counterclockwise. Alright guys, we're almost there. Let's go ahead and look at the last few examples down at the next page. Okay, so let's see what's being asked for us here and then see if we can figure it out together. So it says, use triangle JKL with vertices 2, 6, 5, 2, and 7, 5 to create triangle J prime, K prime, L prime by rotating JKL 90 degrees counterclockwise. 90 degrees counterclockwise about the origin, and then graph the figure and its image after the specified rigid transformation. Okay, so we're going to go ahead and do this transformation of 90 degrees rotation. So let's go ahead and do it. First off, why don't we go ahead and graph JKL. So JKL is 2, 6, K is 5, 2, and L is 7, 5, just like that. So let's finish off our, our picture here. Alright, so we know we have to rotate this 90 degrees. So my rule is going to be x comma y is what? Well, if you're ever not sure, go back up. That's why I emphasize these charts. So it's x comma y turns into negative y comma x. Negative y comma. Okay? So let's do it. So if my original was K, L, what were those original coordinates? They were 2, 6, 5, 2, and 7, 5. But now we're going to rotate them 90 degrees counterclockwise. So let's see what we get. Well, again, my y is now going to turn into a negative and then switch roles. So this is really going to be a negative 6, 2. This would be a negative 2, 5. And this a negative 5, 7. This is my J prime, K prime, and L prime. So I'm going to go ahead and graph that. Negative 6, 2 is right up there. Negative 2, 5, and negative 5, 7. And I'll name them correctly. This is J prime, this is K prime, and this is L prime. That is exactly what you should have. This is what helps you determine all of those new coordinates, guys. You have to make sure you know this. Okay? Any rotations, and actually for any sort of transformations, really, you're going to need to know what that specific rule is. And this is the rule for 90 degrees counterclockwise. Alright? Okay, that one was fairly simple. This is where it starts to get a little trickier because we're incorporating every single thing that we've done so far. Okay? So let's make sure we know how to do this. So it says, given triangle MTZ perform the following transformations in order to map mtz into m prime, t prime, z prime. Notice we are doing three things here, guys. We have to follow step by step all of these. First, we're going to rotate 180 degrees counterclockwise. Then we're going to reflect across the x-axis. Then we're going to reflect across the line y equals negative x. Okay, so let's see if we can do this. All right, first off, m, t, and z. Let's write down what the original coordinates are. Okay, our original coordinates are for m, negative 5, comma 5. And then we are going to do t, which was negative 5, comma 9. And finally z, which is negative 9, comma 6. Okay, so the first thing that we are going to do, go ahead and do this in red. First thing we're going to go ahead and rotate it 180 degrees. So the first thing that we're going to do. Okay, now to rotate 180 degrees, we know we're going to have to follow this rule. It's going to be x comma y turns into negative x comma negative y. So let's go ahead and do it. So this is now a new set of ordered pairs. This is now going to be 5 comma negative 5, 5 comma negative 9, and 9 comma negative 6. Notice we didn't switch any positions. All we really did was just go ahead and make all of them negatives, all right, or make them opposite of what they already were. Okay, I'm all done with that. My second portion, which is reflect across the x-axis. Okay, so now my second thing is going to tell us to do what? Let's see if you guys can remember this. What is this going to make us do, guys? Hopefully you guys remember. All right, and a reflection over the x-axis, and let's pretend that we had to do this. It's going to take this and bring it down here. Okay, so that means only your y's are going to change. Your x stays the same. So that would be x comma negative y. So let's do it. This is going to be x stays the same. My y changes to a negative, or in this case now into a positive. X stays the same, changes to a positive. X stays X stays the same, y changes to a positive. All right, and we have one final one. Reflection across the line y equals negative x. And this one is our final one. And this one tells us to do this. X comma y needs to be changed, not only switched, not only is the y going to be here and the x going to be here now, but we're going to have to make each of these negative. Okay, so let's take our coordinates from our second step and make them now negative and switched, negative and switched, negative and switched. All right, that is what we are going to have. Okay, guys, so now let's go ahead and actually draw these things. Let's make sure we have them. So the only one that we really want at the very end is this third step, but let's see all the steps in between. So in red, I'm going to have 5 comma negative 5. 5 comma negative 9 and 5 comma negative 6. Oh, I'm sorry, 9 comma negative 6. 9 comma negative 6 is right here. Okay, that was one. Oh, sorry guys, let me get my charger real quick. Alright, sorry about that, guys. Kind of thought we were gonna get disconnected here, but now I got my charger connected. We can keep going. Alright, so where were we at? So we had just reflected, so we had done this first step. I'm sorry, not reflected, we rotated 180 degrees. So that's my first step. My second step was to go ahead and reflect over the x-axis. So that gave us a new set of coordinates, which were 5, 5, 5, 9, and 9, 6. And once we had that, we had our final transformation, which was to reflect over the line y equals negative x, which gave us our last set of coordinates, which were negative 5, negative 5, negative 9, negative 5, and negative 6, negative 9. And just to make sure we are on the same page, this is my m prime, my t prime, and my z prime. So m prime, t prime. Oops, I think I went a little too far. Yeah, I did. I think I did my t a little too far out. Right there, there we go. So this is t prime, and finally this is z prime. That is what your final figure or your final image should look like. So again, yes, these right here were all important, but really the one we want is this one. This is the one that shows us our final position of triangle m prime, t prime, z prime on our coordinate plane. Okay, so we're going to go do something very, very similar right here. So why don't you guys go ahead and try number 9 out on your own. Go ahead and give that a shot, guys, and we'll come back and talk about it when you're done. Alright, guys, so hopefully you had a chance to try this out. So let's make sure we know exactly what we're doing. First off, we are going to reflect over the x-axis. I'm sorry, the y-axis. Sorry about that. Second thing, we're going to rotate our figure 90 degrees counterclockwise about the origin. Third thing, we are going to go ahead and reflect across the line y equals x. And as a very final step, we're going to apply the rule x comma y equals x plus 8, y plus 2. So final translation here. Okay, so let's go ahead and do it. Well, first off, we need to know the order pairs that we were originally given. So my A, B, and my C. Let's go ahead and write the originals. So it looks like we are at 2 comma 3. Other way around. 3 comma 2. And then we are at 5 comma 5. And then we are at 9 comma 2. Okay, I think that's correct. All right, so let's see what we're doing first. The first thing we're doing is we are going to reflect over the y-axis. So what does that mean? That means we are turning all the x comma y's into negative x comma y's. Okay, so let's do it. And again, guys, if you're wondering where I'm getting these right here, this is from the previous videos. So if you don't know how to do these, that's probably because you haven't taken your notes on the previous video. So please go back to those and make sure you understand how to do those. All right, so let's go ahead and write our new coordinates. This is going to be negative 3 comma 2, negative 5 comma 5, and negative 9 comma 2. And just so we can keep everything on track, I'm going to actually go ahead and graph this in red. Again, the final one that we actually want is this last one. That's going to tell us our final position. But in the meantime, we can actually track where our triangle is by graphing it. Okay, so let's go to negative 3 comma 2, negative 5 comma 5, and negative 9 comma 2. And as you guys can see, that already looks like a nice reflection over the y-axis. Alright, next thing we're going to do is go ahead and rotate 90 degrees counterclockwise. So in blue is my second thing, and we're rotating 90 degrees. And again, this one is right up here, so you can go right back up. That's why these charts are important, guys. 90-degree rotation was x comma y is negative y comma x. So I'm changing my y to a negative, and then I'm flipping roles. So I'm making my x my y, and my y my x. So let's do it. So this one right here. For a, we're going to switch them and then make the y the negative. So this is going to be negative 2 comma negative 3. This is going to be negative 5 comma negative 5. And also negative 2 comma negative 9. Once again, to track it all down, let's go ahead and graph it. So this is negative 2, negative 3, negative 5, negative 5, and negative 2, negative 9. That was a good 90-degree counterclockwise rotation. There we go. All right, move on right up to step 3. Now we're reflecting along the line y equals x. So this is going to be a whole new set of ordered pairs. This is when x comma y turn into y comma x. So let's do it. So now I'm really just switching the rows. I'm not switching any symbols or anything like that. So I'm just making this negative 3, negative 2, negative 5, negative 5, and negative 9, negative 2. Let's draw that. So negative 3, negative 2 is right here. Negative 5, negative 5, and then negative 9, negative 2. That's what that looks like. And then finally, as a concluding transformation, forward. Yeah, that doesn't make sense. Fourth. Wow, that was pretty bad. But anyways, all right, let's go ahead and do our fourth transformation. And that is a small translation that tells us to apply the rule x comma y turns now into x plus 8, y plus 2. So my image is going to stay almost exactly the same as that green one. It's not going to move around anymore in terms of rotating or reflecting, anything like that. Now it's just going to slide over. It's going to move over. So if I add negative 3 plus 8, I'm going to actually get 5. And if I add negative 2 plus 2, I'm going to get 0. So negative 5, 0. And then I'm going to get negative 5 plus 8 is going to be a positive 3. Negative 5 plus 2 is a negative 3. And then finally, negative 9 plus 8 is a negative 1. And negative 2 plus 2 is 0. So my final coordinates for this is going to be 5, comma 0. This is going to be my A prime. 3, comma negative 3 is my B prime. And my C prime is negative 1, comma 0. This is my final diagram. All right, ton of work for this problem, but it kind of brings across every single type of transformation we've done in this chapter. Okay, all right, guys. I think that's it for me. This has been the last video of the 4.2 or sorry 4B chapter transformation. So you guys, if you haven't already, make sure you watch the ones previous to this to make sure all of this makes sense, as we did cover everything in the previous videos. Alright guys, that's it for me, and I will talk to you guys on the next one. See ya.